Assalamualaikum and hello everyone. I am Anish Hazwani binti Apandi and I'm from group 7. For this week, I am the leader for the group, which is for experiment 3, major losses in pipe. There are 4 members in the group, which is me, Anis, Tariq, Zulkifli and Yongkan.
So, hi everyone, I'm Datuk Z. As usual, you guys know me. So, let's talk about abstract of this experiment. So, the main aim of this experiment was to determine the part friction factors and the resistance coefficient to show how the friction factor varies with Reynolds number by manipulating the flow rate of the fluid in a pipe. And talking about the major principle used in this experiment is the Bernoulli equation and taking major head losses into account. And we in this experiment we neglect the minor losses. And these major losses will be normally due to the wall friction in the pipe and also the viscous forces between the layers in the fluid. That's all.
Hello guys, I'm Tariq. So these are the objectives. We have 3 objectives here. The first one is to measure the friction losses of flowing fluid in the pipe that affected by the flow rate, pipe diameter, and surface roughness. Second one is to explain the factors that affecting pipe selection based on major head losses. And then the last one to determine the factors that affecting inaccuracy of data.
Alright, next will be the introduction. In this experiment, the pressure loss or the head loss for a flow which subjected to the friction will be determined experimentally. The flow also considered steady at Reynolds number, which more than 2320. With turbulent pipe flow, the pressure loss is proportional to the length of the pipe, coefficient of the pipe friction, density of the flowing medium, and last but not least is proportional to the square of the flow speed.
Okay, these are the theory. Basically, in this experiment, we're using a lot of theory. The first one is pressure loss formula, and then we also have head loss formula, and then the last one here, we also have a table for searching roughness based on the pipe. If the RE higher than 2320. Next, please. So this is the Moody chart. This one shows the relationship between RE, F, and roughness is shown in the diagram. Here, the wall roughness, or E, is related to the pipe diameter. Next, please. Okay, this is a table for kinematic viscosity of water as a function of temperature. We use it for equation 4. Next, please. So we also have RE formula, flow speed formula. Okay, the table before this slide, we are using in this equation for equation number 4. And then we also have Blasius formula for hydraulically smooth pipes. And the range of Reynolds number between 2020 and less than 100,000. Next, please. Okay, this is the last theory. For pipes in the transition, we use this formula. And then we also have Moody formula.
So now we will enter the methodology part. So you can see the apparatus we will use in this experiment. So the important part include the pump switch, main switch, the return hose, return wave, water tank pump, the various measuring sections, the place where we put all the pipes, the feeding hose, jet wave, thermometer, rotameter, two-tube manometer, and the differential pressure sensor. Next. Procedure of the experiment. So first, both feeding and return hose are connected to the test pipe station. So at the left is the feeding hose and the right is the return hose. The manometer tube is connected at one of the two-tube manometers, H1 inlet and H2 outlet to the test pipe station. So the left image you can see that he connect the manometer tube to the left side of the two tube manometer, which the H1 inlet, and the right image is he connect to the H2 outlet of the two tube manometer. Next. Yeah, so this is the third step. The main switch and the pump is turned on. So the above one is the green button is the pump switch, and the red one is the main switch. So after that, the gate valve will be slowly open until a reading of rotameter or the actual flow rate is reached 2 meters cube per hour. The fifth step is the ventilation valve, the black one on the top of the two tube manometer is open to let the water overflow from the system. So from the image you can see it open the ventilation valve by the anti-clockwise direction, and the water will be overflow and the bubble will be released, so can prevent the error to occur in the experiment. Next. After that, close the gate valve and turn off the pump. The ventilation valve now is the white one on the top of the two tube manometer is slowly open until a preset minimum reading of two tube manometer. So this is an example of the what you need to adjust is 25 millimeter for galvanized steel pipe and PVC pipe, and 1 millimeter for the copper PVC20 and PVC32 pipe. So number 8 is the gate valve is slowly open until the level of water at 2 tube manometer of H1 reach the maximum, while the H2 at minimum. So for left side image you can see the H1 is at the maximum and H2 is the minimum. So after that, you need to record the two tube manometer reading, temperature, and the actual flow rate at the rotameter. Next, the actual flow rate is reduced to 5 different waves by adjusting or reducing the opening of the gate valve. All the reading is recorded, including the H1 and H2, temperature, and the rotameter with the actual flow rate. So the minimum value of actual flow rate should be around 0.2 meter cube per hour. So next, the manometer tube and the two tube manometer is transferred to the differential pressure sensor, T1 inlet and T2 outlet. So you can see for the left side image, the two tube manometer, the manometer tube and the two tube manometer is transferred to the right side image, the differential pressure sensor. So the flow meter value is adjusted on previous reading. Then the reading of differential pressure sensor is recorded. Then the actual flow rate is reduced to 5 different values, same as per data before. The reading of differential pressure sensor is recorded. After that, the gate valve is closed and the pump is turned off. Now the feeding and return hose is changed to another pipe station. So for step 2 until step 16, the step is repeated for the other pipe. So after finish, all the manometer tube is removed from the system, the gate valve is closed, and the pump and the main switch is turned off.
Alright, next will be the results of the experiment. Table 3 shown the data for galvanized steel pipe, which we already have the given data, which is internal diameter 12.7 millimeter, and also the length of pipe, which is 1000 millimeter. Alright, table 4 shown the data for the copper pipe, which there are few given data, which is internal diameter 18 mm, thickness 1 mm, and also length of the pipe 1000 millimeter. Alright, next is table 5, data for PVC pipe, which there are few data given, which is internal diameter 20 mm, thickness 1.5 mm, and also length of the pipe 1000 mm. Alright, next we will get the data for PVC pipe, which is shown in the table 6. There are a few data here, which is internal diameter 16 mm, thickness 1.8 mm, and also the length of the pipe 1000 mm. Alright, last but not least is table 5, showing the data for the PVC pipe. For internal diameter 32 mm, thickness is 1.9 mm, and also the length of the pipe is 1000 mm. Alright, next is the discussion. For the first question is, compare the coefficient of friction for each of the tested pipes in the experiment with the coefficient of friction from Moody chart and calculation using a formula of Blasis, Colebrook, and also the Moody. Explain the possible reasons for the differences in the values. Alright, so this is the calculation for the galvanized steel pipe. To get the velocity, we'll get the 0.8771 meter per second, and then we get Reynolds number 13,908.32. And at the left side in the box is the given data. Alright, this is the steps or calculation to get the coefficient of friction. When for the Moody chart and Colebrook formula, I'm using the Microsoft Excel to get the values, which is for Moody chart we get 0.041, and for Colebrook formula we get 0.041, and from Blasis formula I got the coefficient of friction is 0.029, and from Moody formula I got 0.058. Alright, next will be the copper pipe. At the box at the left side is the given data, and then we have to find the internal diameter, which is 0.016 meter, and then we will get the velocity, which is 1.243 meter per second, and Reynolds number 25,751.65. Alright, so here is the calculation to get the coefficient of friction. So for Moody chart and Colebrook formula, I'm using the Microsoft Excel. I got 0.024, and for the Colebrook formula, I got 0.025. And from the Blasis formula, I got the coefficient of friction is 0.025, and from Moody formula, I got 0.047. Alright, next will be the PVC pipe. For the length of 20 mm times 1.5 mm, I got the velocity 0.5507 meter per second, and I got Reynolds number, which is 12,350.30, and at the left side in the box is the given data. Alright, now is the calculation to get the coefficient of friction. For Moody chart, I got 0.029. For Colebrook formula, I got 0.029. And from the Blasis formula, I got 0.03. And for the Moody formula, I got 0.06. Alright, next will be the PVC pipe, 16 mm times 1.8 mm. At the left side in the given data, so to get the velocity, we have to substitute the given data into the equation, and then we will get the velocity is 2.3 meter per second, and Reynolds number 38,718.44. Alright, so for the calculation of the coefficient friction, from the Microsoft Excel, for Moody chart and Colebrook formula, I got the same value, which is 0.023. From Blasis formula, I got 0.023. And for the Moody formula, I got 0.041. Alright, so last but not least is the PVC pipe with the length of 32 mm times 1.9 mm. So at the left side in the box is the given data. We have to substitute the given data into the formula for the velometer and Reynolds number. For the velocity, I got 0.756 meter per second, and for the Reynolds number, I got 29,224.4. Alright, next will be the coefficient of friction. For the Moody chart and the Colebrook formula, I got from Microsoft Excel, and both are the same value. Same goes to Blasius's formula. I got the same, which is 0.024. But for the Moody formula, I got different value from these three methods. I got 0.045 for the from the Moody chart. From the Moody formula. Alright, so the reason why there are the differences between these coefficient values between these four types of method. So in order to calculate the coefficient friction, some aspects need to be taken into consideration in the calculation. It depends on the type of the flow, such as laminar flow, turbulent flow, and also the transition between laminar and turbulent flow. So the values of F that obtained from the Moody chart for all types of pipe except for the galvanized steel pipe, they are the same as when they calculated by using the formula of Blasius and Colebrook, but they are slightly different when using the formula of Moody. This is because the Moody stated the accuracy is about plus minus 5% for smooth pipe and plus minus 10% for the rough pipes. However, for the galvanized steel pipe, the value obtained from the Moody chart and the Colebrook formula are the same, but there are huge difference between when using the formula of Blasius and Moody formula. This is due to the process of calculation of Colebrook formula, which more details compared to the Blasius formula that only required few parameters in the calculation. While in the differences of the value obtained from the Moody charts and Moody formula, it is because Moody stated the accuracy is about plus minus 5% for smooth pipe and plus minus 10% for the rough pipes. Alright, next question is rank the pipe in ascending trend based on their major head loss value obtained from your experiment. Briefly explain on the reasons that influence the pipe ranking selection. So for galvanized steel pipe, I got the head loss 0.1266 mm. And how to do it? Just substitute the given data in the box at the left side into the HL formula, and then we will get the head loss formula for galvanized steel pipe, which is 0.1266 meter. And then for the copper pipe, just use the same method, substitute the given data into the head loss formula, and then we will get the head loss is 0.09503 meter. Alright, so for the PVC pipe, I got the head loss 0.02241 meter. And for the PVC pipe 16 mm times 1.8 mm, I got the head loss 0.5 meter. And then for the PVC pipe 32 mm times 1.9 mm, I got the head loss is 0.0248. Alright, so this is the ranking ascending trend, which is the lowest one is PVC pipe 20 mm times 1.5 mm, and then followed by PVC pipe 32 mm times 1.9 mm, and then copper pipes, and then galvanized steel pipe, and last one is, and the highest one is PVC pipe 16 mm times 1.8 mm. Alright, so based on the experiment concluded, PVC pipe with the dimensions of 20 mm times 1.5 mm give the least head loss compared to the other pipes. This is due to the fact that it has relatively lower velocity and friction factor, as well as the big internal diameter. Head loss is proportional to the friction factor and velocity, whereas inversely proportional to the diameter. Alright, so the third one is the factor contributing to the errors and inaccuracy in this experiment, and what is the possible recommendation to improve the existing results. So for the errors, the first one is presence of air bubbles in the tube as well as in the pipe. parallax error due to the incorrect position of the eyes to the scale, and last but not least is the water level in the two tubes manometer cannot be calibrated if fluctuates heavily. Alright, next is the recommendations. Make sure there is no air bubbles trapped in the tubes or the pipes. Next, make sure the position of the eyes is perpendicular to the reading scale. And last but not least, adjust the volumetric flow until it do not fluctuate. Or what we can do is take the average of the reading.
So the conclusion of this experiment is this experiment conducted fulfilled the objective, which is to determine the part friction factors and resistance coefficient. The calculation made was based on the equation 1 to 6 given in the theory, and equation 4 to 6 were used based on the requirements of the calculation. The equation 4 to 6 also apply the Blasius formula, Colebrook formula, and the Moody formula. Moody chart and kinematic table is also referred in order to obtain the values needed. However, this experiment involved with some errors which affects the accuracy of the result. Therefore, some recommendations are needed in order to get more accuracy during handling of this experiment. So the recommendation are make sure there is no air bubble trapped in the tube or pipes. And the second one is make sure the position of the eye is perpendicular to the reading scale. And last but not least, adjust the volumetric flow until it do not fluctuates or take the average reading.
Alright, so for the last part of this presentation is the references. So there are 3 references that we are using in order to get or to complete this lab report. So yeah, for the information, you guys can refer all of these 3 references. Alright, so thank you everyone. That's all from us.
Bye.
Thank you.
Bye-bye.
Thank you.